All right, everyone, we are back, and so we're looking at some measurements of sounds that sperm whales make when communicating in terms of voltage versus time. So we see these values in terms of seconds: -5, 5, 10, -5, 5, 10, -5, 5, 8, -5, 5, 10. That is clearly an aperiodic signal. So we can start to define some values. So my del T is equal to 0.01. My F sub S is equal to 1 divided by del T. My number of points, big N, is going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's double count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my big N. My F Nyquist is going to be F sub S divided by 2. My del F is going to be equal to 1 divided by big N times del T here. So those about actually my period. Actually, yeah. Well, my period is 1 divided by del F. So that will be my period T. So T equals this. So 1 over T will give me my del F. You could also double check that F sub S divided by big N. That should also equal to my del F. And we got those values. So period, got it. Sampling frequency, got it. Nyquist frequency, got it. Big N, delta T, delta F, fantastic. What's the lowest frequency? Del F. Maximum frequency, again, I can only plot to my Nyquist frequency, which is going to be also equal to my big N divided by 2 times del F. And what do you know? Those match. Fantastic. Dominant frequency, I'm going to figure out. There will be 6 terms in this, this value here. So this is clearly a discrete Fourier transform. So to calculate my A sub n, I'm going to do equal to basically a table of 2 divided by big N times, let's go ahead. I need to do a table. I need to grab, first off, I need to create my data. So my data is -5, 5, 10, -5, 5, 10, -5, 5, 8, -5, 5, and 10. So that's my data. So big N, and I need to do a table here. Actually, sorry. Table of, I need to look at my data. Actually, let's go ahead and do data R. So each of these data sets times cosine times 2 times pi times R times N divided by big N. And I want to do that for I goes from 1 to the length of, actually, not I. R goes from 1 to big N. Here, I need to sum that, total this. I need to now multiply this by my, basically, 2 divided by big N, as such. And then, now I need to do this for all the values of N goes from 1, you can see here, N goes from, actually, 0 to big N divided by 2. And there we go. This will be my A sub N. My B sub N will be this. Just be a sign. Now I could do, just like we did previously, transpose. I want a table from I times del F. I goes from 1 to big N divided by 2. And then I want to combine this with basically a table of square root, table of A sub N I squared, actually square root of this, square root of A sub N I squared plus B sub N of I squared, where I goes from 1 to big N divided by 2. And there we go. So we can let's look at those values numerically. So this, you could even do a list plot. Let's get this out of the way here. So I could do a list plot. Look at that frequency spectrum. And clearly the largest harmonic is at 41. So my 1, 2, 3, first harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic. And you can see those values of your first 6 terms. So are all these frequencies real? I cannot measure the 11th, I cannot measure the 14th harmonic. So those are not real. That's it. So that's our problem 2. So we're going to move on to our third problem. I'm going to quit my kernel each time, and I'll see you all in the next video. Thanks. Bye.